Now let's move on to theorem 10.2, and this theorem states that when I draw tangents from an external point to a circle, then their length will be equal. Or in other words, tangents drawn from a common external point are equal in length. That's how we do it. So we draw a circle first, then we locate a point outside the circle, let's call it point P, and then I draw tangents from it, one up, one down. Let's say this one touches at point Q, this one touches at point R, and then I locate the center circle and let's call it O. And now let's connect the center of the circle to the point of contact on both the directions, here at Q, then here at R, these two. And you know that these angles are the angle that a tangent and a radius makes is 90 degree, so they both are going to be 90 degrees. And then I connect point P to point O. Well, why am I doing it? Because I want to prove that indeed the length of these tangents is equal when they are drawn from an external point. That means a point outside the circle. So let's take the triangle PQO and triangle PRO. Now let's see what's special about these triangles. Now you know that OP is the common side in both the triangles, and if you look at it, it is going to be hypotenuse here. Why? Because it is the side against the right angle, or this is the side that is facing the right angle. So this is going to be the longest side. So the longest side is the hypotenuse, and it is going to be in both the cases. Even in the PRO, this is going to be hypotenuse. Why? Because it is facing the 90 degree angle, so it is going to be the longest side, and this is going to be hypotenuse for both the triangles, and it is also the common side. Then we have OQ equals OR because they are radius, so they are going to be equal. Now you have two sides equal, okay, the hypotenuse, which is also common side to both the triangles, and then the radius. And you also know that the angle, the right angle, is common to both. Not common, they both have a right angle. So if you look at it, these two triangles are congruent. That means they are mirror images of each other, or mirror image of each other. So I can say that triangle PQO and triangle PRO are congruent. Why they are congruent? We can use the what's called the right angle hypotenuse side theorem, that when two triangles have their they have a right angle and they have a hypotenuse that is equal and a side that is equal, then they are going to be congruent. And you can think about it another way too. When the hypotenuse is equal, other side is equal, then the third side, if I use Pythagoras theorem to calculate the length of the remaining side, it is going the remaining side are going to be equal because the other sides are equal, and by that, if we apply that formula, they are going to be equal too. So it is going by RHS theorem, it is going the triangles are going to be congruent. And you know that when the triangles are congruent, we can apply CPCT, that means corresponding parts of congruent triangles. So by that rule, we can deduce that PQ is equal to PR. Okay, and in any case, if I apply Pythagoras theorem, I can also come to the same conclusion. The remaining sides are also equal. So my theorem is proved here. PQ and PR are tangents here, so they are equal. I have proved the theorem. Something that I can also use the CPCT property to get one more result is that angle QPO is going to be angle RPO. And why is this important? And if you look at it, then this line that connects the center and the tangent, this is actually dividing the angle in two equal parts. That means it's bisecting the angle. Yes, so we can observe two things from here. First observation is the tangent from a common point outside the circle are equal in length. And second observation is that a line connecting a center circle and the tangent bisects the angle that the tangent make on the point outside the circle. That means the angle QPR is going to be bisected by the line OP. That's what the theorem says.